From our first breath, our lives are intertwined with the pursuit of health and the alleviation of suffering. This journey has shaped medical science, a testament to humanity's indomitable spirit. To grasp modern medical marvels, we must trace the footsteps of our ancestors. Every era has left its mark on medical knowledge, connecting us to pioneers who challenged the unknown. By embracing the past, we appreciate the present and shape a healthier future. In antiquity, medicine was intertwined with spiritual beliefs and rituals. Ancient civilizations developed healing systems based on their understanding of the cosmos. In Egypt, priests served as healers, documenting their observations on papyrus scrolls. The Greeks laid the foundation for rational medicine, emphasizing observation and logic. Hippocrates revolutionized the field with clinical observation and ethical practices. These early endeavors laid the groundwork for evidence-based medicine. Medical progress has been tested by devastating outbreaks of disease. The Black Death spurred efforts to understand contagion and develop public health measures. The Renaissance witnessed significant advancements in medical knowledge. Leonardo da Vinci and Andreas Vesalius revolutionized the understanding of human anatomy. The printing press facilitated the dissemination of medical knowledge. These challenges and innovations shaped the evolution of medicine. The ancient Egyptians applied their knowledge to both the afterlife and the living. Their medical practices combined practical remedies and spiritual invocations. They documented their observations on papyrus scrolls, recognizing the importance of hygiene. Their understanding of the human body extended to the circulatory system. They utilized a vast array of natural resources for medicines and treatments. In ancient Greece, a shift occurred towards reason and observation in medicine. The Asclepion temples served as centers for physical and spiritual healing. Hippocrates emphasized careful observation and treating the whole patient. His teachings revolutionized medical practice, focusing on natural causes of disease. He proposed that illness resulted from imbalances within the body. His emphasis on diet, exercise, and rest laid the groundwork for preventive medicine. In ancient China, traditional Chinese medicine, TCM, emerged, viewing the body as a microcosm of the universe. Health is maintained by preserving the balance of qi, a vital energy. TCM therapies include acupuncture, moxibustion, and herbal medicine. Herbalists create customized formulas to address individual imbalances. The concept of yin and yang represents the duality of nature. Health requires maintaining a harmonious balance between these forces. Ancient medical practices continue to resonate within modern medicine. The emphasis on hygiene and sanitation remains a cornerstone of public health. The Greek focus on observation and treating the whole patient guides medical practice. Traditional Chinese medicine is integrated into mainstream pain management. By acknowledging ancient contributions, we enrich our understanding of health. The term Dark Ages evokes a sense of intellectual stagnation, but medical knowledge endured. Monasteries preserved ancient texts and cultivated medicinal herbs. Islamic scholars translated classical medical texts, expanding upon ancient wisdom. Cities like Baghdad and Cairo became centers of intellectual exchange. Avicenna's canon of medicine synthesized Greek, Roman, and Islamic traditions. The Islamic Golden Age, spanning roughly from the 8th to the 13th centuries, witnessed an unprecedented flourishing of scientific and intellectual inquiry that extended far beyond the realm of medicine. Islamic scholars made groundbreaking contributions to mathematics, astronomy, philosophy, and other fields, laying the groundwork for the Renaissance that would later transform Europe. Their emphasis on observation, experimentation, and the pursuit of knowledge for its own sake had a profound impact on the development of scientific thought. In the field of medicine, Islamic physicians made significant strides in surgery, developing new instruments and techniques for delicate procedures. Al-Zahrawi, a renowned surgeon from Cordoba, Spain, authored a comprehensive medical encyclopedia, Al-Tasrif, that included detailed descriptions of surgical instruments and procedures, influencing surgical practice for centuries to come. Islamic hospitals, often attached to mosques or funded by wealthy patrons, provided medical care to people from all walks of life regardless of their faith or social standing. These hospitals, staffed by skilled physicians and surgeons, offered a level of care that surpassed anything available in Europe at the time. The Islamic emphasis on hygiene and public health also contributed to significant advancements in disease prevention. Cities like Cordoba and Baghdad boasted sophisticated water supply systems and public baths, reflecting an understanding of the link between sanitation and disease that was far ahead of its time in Europe. The Renaissance marked a profound transformation in Europe, driven by a rediscovery of classical texts and a spirit of inquiry. This era revolutionized medicine, emphasizing human anatomy. Leonardo da Vinci's secret dissections produced unparalleled anatomical drawings. Andreas Vesalius further revolutionized anatomy, challenging Galen's teachings. His treatise De Humani Corporis Fabrica presented a new vision of human anatomy. The printing press spread these discoveries, revolutionizing medical knowledge. Vesalius's treatise, with intricate illustrations, spread his findings across Europe. Section 4. Paracelsus and the Seeds of Pharmacology, Challenging Dogma, Embracing Innovation. While the Renaissance witnessed a resurgence of interest in classical medical knowledge, it also gave rise to individuals who dared to challenge established dogma and explore new frontiers in healing. One such figure was Paracelsus, a Swiss physician and alchemist whose unconventional ideas and practices left an indelible mark on the history of medicine, particularly in the emerging field of pharmacology. Paracelsus, a flamboyant and often controversial figure, rejected the humoral theory of disease that had dominated Western medicine for centuries. Instead, he proposed that illness resulted from specific chemical imbalances within the body and could be treated with carefully measured doses of mineral and chemical substances. This radical notion, a departure from the traditional reliance on plant-based remedies, laid the groundwork for the development of modern pharmacology. Paracelsus traveled extensively throughout Europe, studying various healing traditions and incorporating folk remedies and alchemical principles into his practice. He advocated for the use of minerals like mercury and sulfur in treating diseases like syphilis, recognizing their potential therapeutic benefits while also acknowledging their potential toxicity. His emphasis on dosage, recognizing that the dose makes the poison, marked a significant step towards a more scientific approach to drug therapy. Though often dismissed as a maverick during his lifetime, Paracelsus's emphasis on observation, experimentation, and the use of mineral-based remedies planted the seeds for the development of modern pharmacology, paving the way for the development of new drugs and treatments that would transform the practice of medicine in the centuries to come. Section 1. The Germ Theory, Unveiling the Invisible Enemies of Health. The 19th century dawned with medicine poised on the brink of a revolution. While anatomical knowledge had advanced significantly, the underlying causes of many diseases remained shrouded in mystery. Physicians struggled to combat infections and epidemics. The germ theory of disease was about to alter medicine forever. Invisible organisms causing illness was proposed by visionary thinkers. Powerful microscopes and laboratory techniques solidified the germ theory. Louis Pasteur's experiments revealed microorganisms' role in fermentation and disease. Pasteur's work extended to diseases like anthrax and rabies. He developed pasteurization to kill harmful bacteria. Pasteur's discoveries laid the foundation for vaccines. Robert Koch developed postulates linking microbes to diseases. Koch identified bacteria responsible for tuberculosis and cholera. Pasteur and Koch's work proved microorganisms cause infectious diseases. Section 2. A Revolution in Surgery from Bloodshed to Antisepsis. Surgery transformed in the 19th century thanks to germ theory and Joseph Lister's antiseptic techniques. Before antiseptics, infections were common and deadly. Lister introduced carbolic acid to sterilize instruments. His methods reduced infections and deaths. Anesthesia further revolutionized surgery, making complex procedures possible. Ether and chloroform transformed pain management. The search for effective methods to alleviate pain during surgery had long been a pursuit of healers and physicians. Ancient cultures utilized herbal concoctions and alcoholic beverages to dull the senses, but these methods offered limited and often unreliable pain relief. The discovery of anesthesia in the 19th century changed surgery and pain management forever. In 1846, William T.G. Morton demonstrated ether as a surgical anesthetic. This event marked a pivotal moment in medical history. News of ether's properties spread rapidly, revolutionizing surgery worldwide. James Young Simpson discovered chloroform, which quickly gained popularity. Chloroform's faster onset and fewer side effects made it a preferred anesthetic. Anesthesia alleviated suffering and enabled more complex surgeries. Surgeons could now undertake intricate operations, advancing fields like abdominal, neurosurgery, and cardiac surgery. Anesthesia revolutionized surgery, transforming it into a precise and multifaceted discipline. The 19th century witnessed a growing awareness of the link between living conditions, sanitation, and the spread of disease. The Industrial Revolution, while bringing about significant technological advancements, also led to overcrowding, pollution, and squalid living conditions in rapidly expanding urban centers. These conditions, coupled with a lack of proper sanitation and limited access to clean water, created a breeding ground for infectious diseases like cholera, typhoid fever, and tuberculosis. One of the most influential figures in the burgeoning field of public health was Edwin Chadwick, a British social reformer who spearheaded investigations into the deplorable living conditions of the urban poor in England. Chadwick's groundbreaking Report on the Sanitary Condition of the Laboring Population of Great Britain, published in 1842, exposed the horrific sanitation problems in cities and towns, arguing that disease was not simply a matter of individual misfortune, but rather a consequence of social and environmental factors. Chadwick's report, along with the devastating cholera epidemics that swept through Europe in the mid-19th century, spurred governments and public health officials to take action. New sewage systems were constructed, water supplies were cleaned up, and building codes were revised to improve sanitation and ventilation in homes and workplaces. The public health movement extended beyond infrastructure improvements, however. It also encompassed social reforms aimed at addressing poverty, malnutrition, and other factors that contributed to poor health outcomes. Public health officials recognized that improving the overall well-being of populations required addressing not only the biological causes of disease, but also the social and economic determinants of health. The 20th century dawned with medicine poised to conquer some of humanity's oldest foes, infectious diseases. For millennia, bacterial infections had plagued humankind, claiming countless lives and leaving many more debilitated. But the discovery of antibiotics, one of the most transformative medical breakthroughs in history, would usher in a new era in the fight against infectious diseases, offering a powerful weapon against these microscopic enemies. The antibiotic era began in 1928 with Alexander Fleming's serendipitous discovery of penicillin. Fleming, a Scottish bacteriologist, observed that a mold growing in his laboratory had inhibited the growth of bacteria in a petri dish. This mold, Penicillium notatum, produced a substance, which he named penicillin, that proved to be lethal to bacteria but harmless to human cells. However, it would take more than a decade of research and development before penicillin could be produced in sufficient quantities to treat bacterial infections in humans. During World War II, the urgent need for effective treatments for battlefield infections spurred a massive research effort, leading to the mass production of penicillin and its widespread use to treat wounded soldiers. The introduction of penicillin marked a turning point in the fight against bacterial infections. Diseases that had once been death sentences, such as pneumonia, meningitis, and sepsis, became treatable with this miracle drug. The success of penicillin sparked a search for other antibiotics, leading to the discovery of streptomycin, tetracycline, and a host of other antibacterial agents that expanded the arsenal against infectious diseases. Vaccines, a triumph of preventive medicine. While antibiotics provided a powerful tool for treating existing bacterial infections, the 20th century also witnessed remarkable progress in preventing diseases altogether through the development and widespread use of vaccines. Vaccines, based on the principle of harnessing the body's own immune system to fight off disease, had been explored in rudimentary forms for centuries, but the 20th century saw this field transformed into a cornerstone of public health. One of the earliest and most impactful successes in vaccine development was Edward Jenner's pioneering work with smallpox in the late 18th century. Jenner observed that milkmaids who contracted cowpox, a milder disease related to smallpox, seemed to be immune to smallpox. He hypothesized that exposure to cowpox could protect against smallpox and conducted experiments that confirmed his theory, leading to the development of the first smallpox vaccine. The 20th century witnessed the development of vaccines for a wide range of infectious diseases, including polio, measles, mumps, rubella, diphtheria, tetanus, and pertussis. These vaccines, administered to millions of children worldwide, have dramatically reduced the incidence of these once common and often debilitating diseases, saving countless lives and preventing untold suffering. The success of vaccination programs in eradicating smallpox, a disease that had plagued humanity for centuries, stands as a testament to the power of preventive medicine. In 1980, the World Health Organization declared smallpox eradicated, a remarkable achievement in global public health and a testament to the power of vaccines in conquering infectious diseases. Imaging, the invisible X-rays, ultrasounds, and the quest to visualize the body's inner workings. The 20th century witnessed a revolution in medical imaging, providing physicians with unprecedented tools to peer inside the human body without the need for invasive surgery. These technological advancements transformed medical diagnosis, allowing doctors to visualize bones, organs, and tissues in ways never before imaginable, leading to more accurate diagnoses and more effective treatments. The era of medical imaging began in 1895 with Wilhelm Conrad Röntgen's accidental discovery of X-rays. Röntgen, a German physicist, was experimenting with cathode rays when he noticed that a fluorescent screen in his laboratory glowed even when the cathode ray tube was shielded. He soon realized that he had stumbled upon a new type of radiation, which he named X-rays, that could penetrate through solid objects, including the human body. The medical implications of Röntgen's discovery were immediately apparent. Within months, X-rays were being used to diagnose bone fractures, locate foreign objects embedded in tissues, and even detect tumors. X-ray technology rapidly spread throughout the world, revolutionizing medical diagnosis and paving the way for other imaging modalities. In the decades that followed, other imaging technologies emerged, further expanding physicians' ability to visualize the body's inner workings. Ultrasound, which uses high-frequency sound waves to create images of internal organs, became a valuable tool for obstetrics, cardiology, and other specialties. Computed tomography, or CT scanning, which combines X-rays with computer processing to create detailed cross-sectional images of the body, provided even greater anatomical detail, aiding in the diagnosis of a wide range of conditions. Decoding the Book of Life. The rise of genetics and the molecular revolution in medicine. The rise of genetics and molecular biology transformed medicine, unlocking DNA's secrets and revolutionizing diagnosis, treatment, and prevention. The discovery of DNA's double helix by Watson and Crick, based on Franklin's work, was pivotal. Recombinant DNA technology enabled the production of therapeutic proteins, paving the way for gene therapy. The dawn of the 21st century ushered in a new era in medicine, driven by an unprecedented understanding of the human genome. The Human Genome Project provided a blueprint of our genetic makeup, opening up possibilities for personalized medicine, treatments tailored to an individual's unique genetic profile. This revolutionizes drug development and patient care. Immunotherapy. unleashing the body's own defenses to combat cancer. Traditional treatments like surgery, chemotherapy, and radiation are now joined by immunotherapy, which harnesses the immune system to fight cancer. Immunotherapy boosts the immune system to recognize and destroy cancer cells. Our immune system constantly patrols for invaders. Cancer cells can evade detection and proliferate. Immunotherapy overcomes these evasions, unleashing the immune system's full potential. Checkpoint inhibitors block proteins that act as brakes on the immune system. Cancer cells exploit these checkpoints to evade destruction. Checkpoint inhibitors release these brakes, enhancing the immune attack. CAR T-cell therapy modifies a patient's T-cells to target cancer. T-cells are engineered to express chimeric antigen receptors, CARs. CARs recognize specific proteins on cancer cells. Engineered T-cells are infused back to seek and destroy cancer cells. Immunotherapy offers hope for long-term remission and potential cures. It represents a paradigm shift in cancer treatment, offering a powerful new weapon against this disease. Section 3. Telemedicine. Bridging the distance, expanding access to healthcare. The digital revolution has permeated every aspect of our lives, and healthcare is no exception. Telemedicine uses telecommunications technology to provide healthcare services remotely, bridging geographical barriers and improving access to specialized care. It includes virtual consultations and remote patient monitoring. The COVID-19 pandemic accelerated telemedicine adoption. Telemedicine reduces healthcare costs and facilitates early interventions. Despite challenges, its potential to transform healthcare is undeniable. Telemedicine is poised to play an integral role in the future of healthcare. Section 4. Artificial Intelligence. The rise of smart machines in medicine. Artificial intelligence is transforming medicine, from analyzing images to drug discovery, offering faster, more accurate diagnoses and personalized treatments. AI algorithms excel in medical imaging, often surpassing human radiologists in detecting anomalies. AI accelerates drug discovery, analyzing vast data sets to identify promising candidates. Virtual assistants help patients and providers, streamlining tasks and offering personalized advice. Despite ethical concerns, AI's potential in healthcare is undeniable. Smart machines will work alongside human providers, improving patient care and accelerating breakthroughs. Section 1. The Unfinished Symphony, a future of limitless possibilities in medicine. As we stand at the cusp of a new era in medicine, we find ourselves surrounded by marvels that previous generations could only have dreamt of. Diseases that once ravaged civilizations are now preventable with a simple injection. Surgical procedures once fraught with unimaginable pain and risk are now routine, and the very essence of life itself, encoded within our DNA, is being deciphered, offering the promise of personalized treatments tailored to our unique genetic makeup. The future of medicine holds limitless possibilities, fueled by the convergence of genomics, artificial intelligence, and nanotechnology. Imagine a world where diseases are diagnosed before symptoms even arise, and where microscopic robots can deliver targeted therapies directly to disease cells. The symphony of medical progress will continue to evolve, offering hope for a healthier and brighter future for generations to come.